Okay, let's take a look then. So like I said, I'll go ahead and jump to the last two here, 17 and 18, because we haven't done too many word problem kind of problems here. Okay. So let's take a look at those two first and just see what we see. All right, 17. The tire on a bike has a radius of 9 inches. How far does the bike travel if the wheel rotates 100 times? Okay. So you guys can actually well, now that we have GPS and stuff like that, I guess it's not necessary. But back in the day before GPS, you could put these things on your bike that would count how many times your wheel rotated, and then you could, figure out how far you traveled based on how many times your wheel rotated. All right. So, any ideas about how to start here? We have the radius of the tire is 9 inches. And how far does the bike travel if the wheel rotates 100 times? Okay. One full rotation, right? One full rotation of that tire, of that wheel, okay? One full rotation of that wheel, okay? Well, that's the distance around the outside. What do we call the distance around the outside of the tire? Circumference, right? And what is the circumference formula? 2 times pi times the radius. Exactly right. Okay, I'll give you that formula tomorrow, but you'll need to know how to use it. Okay, so in this case, and that's not 2 minus 2 times. So in this case, right, it's 2 times pi times 9, which is, I did it here, sorry, 56.5 approximately inches. Okay, and so if you think about it, right, one full rotation of your bicycle wheel. One full rotation of your bicycle wheel results in you traveling 56.5 inches, right? Because that's one full rotation. That's the distance around the outside, okay? So that's what you get. So then if we want to see how far we go after rotating 100 times, what should we do?
Times 100.
Yeah, multiply that by 100. Exactly right. Okay? And so we get 5,650 inches. Okay? You can leave it like that if you want to, or of course we could divide it by 12 to see. So it's like 470 feet, almost 471 feet, 470 feet. Okay, not that we need to worry about that, but that's the idea there. Okay. Okay. All right, let's try another one here. 18. 18. The minute hand on a clock rotates from the 12 position to the 3 position. Minute hand is 7 inches. Oh, I don't think I need to give you that information. Oh, yeah. Anyway, that's not necessary information here. But anyway, letter A. What is the angle of rotation of the minute hand? If it goes from 12 to 3, what's that angle of rotation? Well, look at the clock there.
3.
To rotate from 12 to 3, what's the angle of rotation in degrees? 90 degrees, yeah. 90 degrees, what direction? Clockwise. Because we're literally going the direction the clock goes, right? If the time is 1 o'clock p.m., what time will it be when the minute hand rotates 120 degrees clockwise? That's a bit trickier to see, isn't it? What's that? 7 o'clock? Well, I guess it's just minute hand, just the minute hand. Only the minute hand is rotating from. So at 1 p.m., where's the minute hand? At 1 p.m., where is the minute hand?
12.
At 12, right? The hour hand is at 1. The minute hand will be at 12, right? So at 1 p.m., the minute hand is at 12. Okay, so all right, and then we want to know 120 degrees. So what part of the circle is that? 125. Okay. How'd you get that? That's not quite halfway. 180 is halfway, so you're a little bit shorter than halfway. Okay, I see what you're thinking there. Not bad. What's the whole way around the circle? What's the whole way around the circle? 360, right? So 120 degrees, what fraction of 360 is 120 degrees? Well, let's see. So let's just put 120 degrees out of 360 degrees, right? What fraction does that simplify to be? Not 3/4. No. What's that? 1/3. It actually simplifies to 1/3. Yeah. So in other words, rotating 120 degrees around the circle, right around the clock, is the same as rotating 1/3 of the way around the clock. Okay? What is equivalent to rotating 1/3 of the way around the clock? How many
30.
minutes is that?
20.
30 would be halfway around the clock. 20 minutes. 20 minutes, right. And you can figure that out by just doing 1/3 times 60 if you like, and that gives you the 20 minutes. Okay? So, if we started at 1 o'clock p.m., that means the minute hand was at 12, and the minute hand rotated 120 degrees clockwise, what new time will we be at? 1:20 p.m. Okay? 1:20 p.m. Okay? The hour hand would also move some too, right? But we don't have to worry about that one. Okay? 1:20 p.m. All right, questions on 18A or B or 17 there? All right. How about any other questions then on anything? Sorry, did I move too fast there? I'm sorry. I don't mean it. Any other questions on any of these? Okay. You can use this tomorrow too if you want to. AJ?
Are you talking about the back or like the
Any other questions? Any questions?
first one?
Number 1? Yeah, sure. All right, so anyone still looking at 17 or 18? All right. Then number 1, all right, so here I'm asking you to evaluate the 6 trigonometric functions. That means I want you to find sine of theta, I want you to find cosine of theta, I want you to find tangent of theta, and cosecant of theta, secant of theta, and cotangent of theta. Okay, and I set them up in this way specifically because sine and cosecant are reciprocals, cosine and secant are reciprocals, and tangent and cotangent are reciprocals. Okay. Now, given the information I have here, which one of these 6 trig ratios can I come up with like that? I can not cosine actually. Yeah, sine, because I have the opposite. Again, think SOHCAHTOA here. Okay, I have the opposite side to theta and the hypotenuse, so that's sine. Sine will be 7/15, and that's all I want you to do for that. That's the trigonometric, that's the ratio that I want you to come up with there. Okay, that's it. You don't have to find what theta is, just figure out what the ratio is going to be. For cosine, well, to do cosine, I need to know this missing side right here. How can I find the missing side if I know 2 sides of my right triangle? Yep, Pythagorean Theorem, exactly right. Okay, if you use, does anyone need me to show how to use Pythagorean Theorem? Yeah, okay. So Pythagorean Theorem, just real quick, I'll just do it over here. Okay, it'll be, I'm just going to call this A, we'll say. So it'll be a squared plus 7 squared equals 15 squared. Okay, so I'll have a squared plus 49 equals, I think it's 225. Yes. Okay, subtract 49 from both sides. You get a squared equals 176. Square root both sides. It's about 13.2. Or 13.3 when I round up. Okay? And at this point, AJ, it's just a matter of using SOHCAHTOA. So cosine then is going to be adjacent 13.3 over the hypotenuse 15. Tangent will be opposite 7 over adjacent, 13.3. And then all of these will just be the reciprocals. So 7/15 becomes 15 over 7. 13.3 over 15 becomes 15 over 13.3.
So you put it all over the base?
So I put it over whatever the hypotenuse is, right? Sine and cosine, hypotenuse is what you put it over. Tangent, you're going to put it over the adjacent leg, which is, in this case, 13.3. Okay, it's using that SOHCAHTOA and your ratios there. That's how you do that, though. Okay? Just using SOHCAHTOA to fill out those trig ratios. Okay? Other questions? Got a few more minutes here. Any other questions? Anything else we're starting? Yeah, Gio.
11 and 12.
11 and 12? All right. Is anyone still right there? No? Okay. 11 and 12. Okay, convert from radians to degrees, degrees to radians. Okay, so to do this, put it over 1. Okay, and we will multiply by a conversion factor here. Okay, we're going to use 180 degrees and pi. Okay, since pi and 180 degrees are the same measure, right? Just one's in degrees, one's in radians. We'll use pi over 180. Now, why did I use pi over 180? Why didn't I do 180 over pi? Because I wanted the degree in the denominator here, so it would cancel with the degree in the numerator there. Okay, 30 degrees is in the numerator. I want the degree and the denominator then over here so it can cancel. And then you just multiply. 30 times pi over 1 times 180. And you simplify that fraction. It simplifies to pi over 6 when you simplify. Yep. Okay. 12, you do the same thing. For 5 pi, you won't multiply by pi over 180. You're going to multiply by 180 degrees over pi. The pi's will cancel, and you'll do 5 times 180, which is 900 degrees.
Wait, can you put the answers on?
Yeah, I'll post the answers up. Yep. Mm-hmm. Yes. Any other set requests for today besides Ava, Nick? Any other set requests for today? Remember, quiz tomorrow. Quiz tomorrow. Okay. I'll post the answers to Google Classroom, but you won't be able to use your phone tomorrow, so I would suggest you copy stuff down.
Mr. Wood.